Hey everyone! Welcome back to the channel. Today I've got something truly groundbreaking to share with you. We're talking about revolutionizing diabetes care with precision medicine. I know, it sounds like science fiction, but it's happening right now. Type 2 diabetes affects over 500 million people globally, yet no two patients are truly alike. Traditionally, we've treated type 2 diabetes with a one-size-fits-all approach. Monitor blood sugar, prescribe insulin sensitizers, and hope for control. But what if we could dive deep into each patient's cells and tailor treatment based on their unique molecular signature? A groundbreaking study published in Cell in May 2025 is bringing us closer to that reality. This study offers the most detailed molecular portrait to date of human insulin resistance, focusing on skeletal muscle. Skeletal muscle is responsible for up to 80% of insulin-stimulated glucose uptake. It's where insulin unlocks cells to absorb blood sugar. Yet, in type 2 diabetes, that lock often jams, a state called insulin resistance. This study analyzed skeletal muscle biopsies from 124 individuals, from healthy to insulin-resistant to full-blown type 2 diabetes patients. Using advanced mass spectrometry, the team profiled over 3,000 proteins and 15,000 phosphorylation sites from each sample. The findings are astonishing. First, insulin resistance isn't binary, it's a spectrum. The researchers used the gold standard hyperinsulinemic euglycemic clamp technique to calculate each individual's insulin sensitivity, known as the M value. Surprisingly, M values among people with type 2 diabetes varied over 30-fold. Some type 2 diabetes patients were more insulin sensitive than individuals with normal glucose levels. Second, the fasting muscle proteome can predict insulin sensitivity. Using only muscle samples collected during fasting, the team developed predictive models that outperformed standard clinical markers. These models were more accurate than fasting glucose HbA1c or BMI in predicting insulin sensitivity. Third, not all insulin signaling is lost in type 2 diabetes. Even in severely insulin-resistant individuals, many canonical insulin signaling pathways remain at least partially functional. Specific branches, particularly involving mTOR and protein synthesis regulation, are selectively impaired. Insulin resistance isn't a full signaling shutdown. It's a selective rewiring of pathways. Fourth, mitochondrial coordination matters more than quantity. While total mitochondrial content didn't differ much across individuals, the coherence and efficiency of mitochondrial protein networks correlated strongly with insulin sensitivity. And lastly, specific biomarkers emerged. Proteins like HSPA2, BDH1, and the LDHB-LDHA ratio were indicative of insulin resistance or sensitivity. These biomarkers were validated in independent datasets, bolstering confidence in their diagnostic potential. This study is a leap forward in understanding insulin resistance at an individual level. It moves us away from vague clinical definitions and toward precise molecular subtyping, critical for designing better diagnostics, stratifying patients in clinical trials, and personalizing treatments. The era of treat everyone the same in diabetes care is coming to an end. Precision medicine for type 2 diabetes is no longer a dream. It's becoming a data-driven reality. Thanks for tuning in, and don't forget to subscribe for more updates on the latest medical breakthroughs. Stay healthy, everyone.